Scorpio hate and Thunder hate. You guys are doing good. The music going. I'm sure YouTube's going. All right, we're good. We have no DMs on Reddit. Let's see if we can find a question. Okay. Why is this negative? Well, I don't know. You tell me. Hey, Skinny. I had to figure out what I should call you. So I'll call you Windex, but there's like 5 Windexes. I'm good. How about you? So asking why this negative sign is right here is my assumption. Find the area bounded by the curve y equals 2x plus 6 in the coordinate axes. So they're showing that it's possible to do this integral with, or like in terms of y as well. Why would it be negative though? Because we're in the negative x-axis? Like, shouldn't that be accounted for by the equation of the line though? What's inside the integral there? Like an underlined x? What does that mean? Y over 2 minus 3. Huh. Do they get a positive answer? Yeah. How to calculate harm that life gives you? Well, that's a hard one. I don't know if mathematicians have worked that one out yet. So it must have something to do with the x's being negative. I'm trying to work out what that is though. Oh, maybe because if you have an integral in terms of x, like we normally see in calculus class, when your function is below the x-axis, you expect a negative area. But this time we have the reverse, where the function is 4x in terms of y. So if we go below the y-axis, we get a negative. I never even knew that, to be honest. Let's confirm this in Wolfram that we do get a negative area. That's weird. Like, the integral is -3 to 0 for what? No, 0 to 6. Ah. 0 to 6. Y over 2 minus 3. Y over 2 minus 3 dy. Oh. They're taking y as a horizontal axis here. You do get -9 though. Skills J. Well, you know, now you have to just figure out what J is. And then you say, you know, J equals Y. Then you have to figure out what Y is. You're making progress. Hey, Stooky. Very nice job on that, like, talk with Penn Center. I was mostly just waking up, so I was watching my phone in bed. But I thought it was super fun to like listen to. So maybe the more intuitive explanation for this person is to, well, fair enough, Eldritch. Sleep well. Thanks for popping in. All right, so I guess I figured out why we're doing this, but now the question is, how do I explain it? We can either give an explanation where we take y as the horizontal and x as the vertical, or we can give an explanation where we keep x as horizontal and y as vertical like we're used to, but then we have to explain. I think it'd be better if we keep x as horizontal. Well, I mean, why does it have to be? Oh, okay. Well, I Sanuxian? I'm sorry if I'm probably pronouncing that wrong, but um, welcome in. Okay, so I think find the area bounded by the curve in the coordinate axes. I feel like it would have been more clear to me if we did the absolute value. If they want the area. Sinuxian. Okay. It's all good? Okay. Well, okay, you know what? Does Paul have an example? Someone asked for the area under the curve. I feel like I don't remember always making it positive. If I got a negative answer, I feel like I would just turn in the negative answer. But I feel like that's not right, and you should make it positive. Oh, okay. I was wondering how you do this integral, but of course it's just 0 because of the bounds. I am more interested. I mean, maybe one day Synoxian, but I don't really know you, so I'd rather collaborate with people who I know better. And you're out? All right. I'll see ya. Hey, $10. How's it going today? It's such a weird. I guess. Okay, you know what? Let's just Google all our problems. Calculus area under the curve. Do you make it positive? Let's see what Google does with this. Like, this is my impression too. I feel like this is maybe poor phrasing on the part of the question. Because if we were in quadrant 1 or quadrant 3, there just wouldn't be an issue. But because we have a difference, or in quadrant 2 and quadrant 4, there actually is a difference when you're integrating in terms of x or in terms of y. Feels like an interpretation thing. Something I didn't realize before. My interpretation scheme check of the orientation of the plane. Rotate CCW. CCW. I mean, coordinate. Cartesian coordinate. W. What is W? I feel slow. Counterclockwise. Oh, okay, never mind. No, it's okay. Rotate counterclockwise from the positive variable to the positive dependent variable. Right. I'm not sure how like a rotation would change the sign. I mean, I guess I see how because you know it does change the sign, but like I guess it doesn't completely sit right. I think the extension like I'm kind of like leaning towards is like in the same way when you go below the x-axis you get a negative area in normal situations. If we go below the y-axis, you know, instead of below we say to the left, you get a negative area. But there's something, what was kind of strange was that there's nothing wrong with a negative area in the calculus sense, I guess. But there's something the area bounded by the line and the coordinate axes, so maybe that's why they just really want the absolute value. It's just a weird thing. I had never run into this issue before with changing with a sign flipping when you integrate the same thing with respect to a different variable. Hey, day by day. Oh, that's IE, isn't it? Hey, Jed. Oh, you saw it too. Awesome. Yeah, uh it reminded me of the of a paper. I have one academic paper with my name on it from when I was a research assistant doing my bachelor's, and it made me think of that like experience. It was a really fun time. I want to dig the actual paper like back up too. Yeah, Stuki. I think that's they phrase it like it's presented in a very weird way to me, but I think that's all that's happening. To be negative because if we have a normal function for y in terms of x, the area becomes negative if you go below the x-axis, the negative y's. If we take the same function and re-express it for x in terms of y, we also get a negative area if we go below the y-axis, which is to the left, where the negative x's are. Okay. Gonna work all day. Had to miss that. We find time to check. Oh yeah, I highly recommend it, Fembox. Dealing with area such volume while rotating a curve, you almost have to ignore the sign. Consider. Oh, because does that happen in the calculus? I guess if you use spherical coordinates, that problem is taken care of. But you could integrate just the Cartesian coordinates for a sphere without two. Can you get the volume of sphere in Cartesian coordinates? Now I'm curious. Your integral would be. I think you would take half and multiply by 2. So yeah, you might be right. You said the Earth is a sphere. That's true. It's an oblate spheroid. Or you can also think it's flat, I guess, which would make the calculus problem a lot simpler. The Earth is a sphere. It's a perfect sphere. There's no mountains, no valleys. Perfectly. Yeah, I mean, in that sense, it would be perfectly flat. Just the space is curved. That's the real flat Earth theory right there. Beneath an intergalactic bathtub and measure displacement? I think so. Yeah. Relative motion? See, okay, I doubt I can do this problem, but I'm just curious what if this is just like a translation thing or if they're actually doing relativity in 12th grade. Oh, I mean, I guess okay, it's maybe I don't know. I don't know where relativity actually begins, but I think it's like it's not like E equals MC squared or stuff like that. Go to learn math. Triangular plane intersection question. I feel like I've done a problem like this before. I probably should, like, this is, I mean, what, they make a triangle in a fourth plane though, wouldn't they? This is a very applied version of it though. It's also where Reddit falls very short, since there's no LaTeX. Yeah, I don't know. This is those are too many words for me. What is this? Copy paste it into a calculator. Okay, so let's not into it. Find a power series representation for the function, determine the interval of convergence. For that bad boy. Yeah. So this is just a known power series. So I don't mind that. They got confused when setting the inequality. Alright, so let's take a deeper look at this. I think they used the right technique here. Bring the expert out front. I mean, I guess it could even be your A. Hey, Frederick. Yeah, sure. Factor out the x to the fourth. So, yeah, I mean, if you want to call it a geometric series, your A would be 1 over x squared. R is minus 16 over x to the fourth. Oh, yeah, I mean, okay. I don't see an issue with this. So they said they got confused when setting the inequality, which is for a geometric series to converge, you need your rate to be less than 1. Well, the absolute value of your rate to be less than 1. So, kind of an interesting question, because 16 over x to the fourth is always a positive number, but there's a negative sign stuck in front of it. What are they doing here? I don't think that's what you want to do. What? What happened here? I think I'm overthinking this stuff with the negative sign. Hey, Henrik, how's it going? Playing DayZ still? You would really want to set the inequality -1 is less than 16 over x to the fourth is less than 1. And you're only going to use half the interval because it's going to always be a negative number, but you don't have to worry that much about it. you would need to do some inequality flipping magic, which we can do. You need to do it on the whiteboard though. And Frederick, just type the question out there in chat if you want. Fine, thanks. Started the new job. Oh, cool. I'm doing good. Thanks for asking. You don't have to say if you don't want, but what are you doing for your job? All right, so we deal with the absolute value is we take this, make it negative, put it on that end, and then we take the absolute value so we can get rid of the negative sign. Now, how does this work? We want to solve this, we want to isolate x. So let's flip, take like the reciprocal of everything, which means we also have to flip the inequality signs. That doesn't look right, does it? Would this be cleaner if we broke it out into two separate? I think it'd be cleaner if we broke it out into two separate inequalities, right? Because what I just wrote feels very odd. Okay, so let's back up. Let's say -1 is less than 16 over x to the fourth, right? And we also have 16 over x to the fourth is less than 1. And then we'll do the same operations to each one, but I want to keep them separate because we might get something with, I mean, there should be values of x that this is fine for. Like x to the fourth should be greater than 16. Still play some DayZ, that's good to hear. You don't enjoy the job, but you shouldn't complain. Fair enough. New jobs are always rough. All right, I guess now let's do some flipping stuff. I don't know, maybe I was getting scared about nothing with breaking out into two inequalities, but there's nothing wrong with what I'm doing. So like, okay, -1 is greater than this. I was getting confused, like, I need to make a number line here, because if -1 is greater than that means you're going like there. And if this is greater than 1, it means so I was worried that we're getting no intersection. This is already not valid. This is always a negative number. Yeah, that's why I was getting confused. Okay. I think what we want to do instead is chop off the part of the interval that we don't need, right? Because 16 over x to the fourth is always positive. You have a negative sign stuck in front. So the absolute value is going to be between 0 and +1. And we work with that inequality. But then we run into an issue with we can't flip 0. This is one of those weird inequality things. Now it's outside of -1, 1. Yeah, hard luck. Yeah, Fembox, like that's part that was confusing me. Oh, Frederick, whatever you wrote, it didn't show up for me for some reason. Whatever that long text was, I can't see it. So, okay, now the issue here is that we can't flip 0, can we? Why does this not work? Like, I feel like I already know what the answer is supposed to be. I just me to actually prove it. Here, can we just ignore the part that I don't like? I just want to do this. It's like, I already know what the answer is. It's just writing it down algebraically. That's weird. The fourth root of 16, is that just 2? It is. Because if you just need this entire fraction to be less than 1, then the denominator has to be bigger than the numerator. If you flip a positive number smaller than 1, what's wrong, Jed? Where x is less than -2. Okay, so I guess that's why you shouldn't just chop off the parts of the problem you don't like. So, okay, I mean... Okay, well, let's try to, like, write this down, because it'd be... Okay, yeah, so -1 would be less than 16 over x to the fourth. Do we run into issues here if we flip stuff? We do run into issues that don't actually flip stuff, right? Dude, why are inequalities so hard? See, now, okay, yeah, that's what I was scared of. Because that's technically not valid. I know it should be valid. I don't like the exponent, so let's just get rid of that. The solution's still the same, right? Yeah, exactly. Dividing by a negative flips the sign. I didn't divide by a negative. Did I? Frederick, I don't know, like 200 something subs? But I don't know, I don't really care about my sub count. But yeah, I don't know your question is, Frederick. I'm not sure why it didn't show up. Okay, can we... It's like, this is annoying. I know what the answer should be. Can we, like... Let's do this in a completely different way. It's like... I just want to have the actual work being... I want like good work to show. Let's split up the absolute value before we even think about anything else. Let's say absolute value of -1 times the absolute value of 16 over the absolute value of x to the fourth is less than 1. That's +1, that's 16, so we really just get 16 over the absolute value of x. We can even do this to the fourth, bring the power outside, right? Like, okay, this would be... It's just annoying that we have to do it like this. I don't know how else you're supposed to do it, though. Because I keep running into, like, issues any other way. And this is where we get... It's... What? Is this the song? It is the song. Oh my god. Okay, sorry. I was like, I was hearing SpongeBob and I was like, what is this? So, okay, the absolute value would have been that x is greater than 2 or that -x is greater than 2, right? Which implies that x is less than -2, which that makes sense. Okay, that gets us our answers. I hate having to do it like this, but that's the only like algebraically valid way I can think of to get to the right answer. You don't know what was going before? Me neither. Even exponents always produce positive numbers. Yeah, Jed. He's a bit different, but it looks good. If there's a better way to do this, math professor, I would love to hear it, because this was so unintuitive to me. Okay, actually, what is it? Because this person's work makes no sense to me. When you do square roots to remove that root forward, don't you need the plus or minus signs? Yeah, that's still true with the fourth root that I took, I think. But it gets taken care of with the absolute value anyway. It doesn't end up mattering. Rearrange kid equal to 0, set numerator and denominator equal to 0. Oh, so that's actually the technique that this person used. I haven't seen it before, I don't think. Or I assume it's a technique they use. They kind of skipped over the... Well, no, I don't think we're getting into complex numbers here. We're talking about the radius of convergence for a power series. Sometimes issues the denominator causing regions that work or do not work. Ooh. So at least from this person's work, I mean, I guess let's verify their work. So yeah, you get x equals plus or minus 2 or x equals 0. X can't be 0. It's possible values, but between 0 and 2 and 2 might work and might not. So yeah, we want to test less than negative 2, negative 2 to 0, 0 to 2, and 2 to infinity. Like, we'd have the four regions there. Correct? Okay. I guess that's a cleaner way that avoids issues that I was running into with, like, square rooting negatives, or I guess fourth root rooting negatives. So what was there? Do some funny algebra stuff to get in the form, right? I guess we can give saves all around to everyone who contributed. I'll scroll up in chat and look through unless you want to start handing them out, Jed. So I assume equality to avoid issues with inequality slipping. Yeah. That does make it simpler. Slowly rebuilding. All right. 5 isn't bad. You know, this is a weird... What is the center? Determine. Okay, you'll need the interval of convergence according to this what the directions were, but they're bringing the center of the center, which I don't know how you get the center of two disjoint things like that. Like, I could call it 0, but I don't know if that's actually right. And I guess these have kind of similar issue with the radius. Like, I'd be willing to call the radius infinity, but I feel like that's kind of lazy. You're talking about the universe is there's your kid? That's fair. Okay, so maybe I want to ask this person if they actually need to get the center in the radius, or if all they need is the interval. Oh, no worries. Their main question is about the radius of convergence part, or like where this geometric series converges, which is how we got on this inequality stuff. but their solution looks correct to me. I didn't see anything in their work that looks wrong. If it's alternating, doesn't it just always converge? Because the limit goes to 0? What do you need? Well, what do you need for? Oh, does it need to be like monotone decreasing? And it might not be if x is between 0 and 2. Oh yeah, okay, so if x is between -2 and 2, you don't have a decreasing sequence, which is the issue. Okay, never mind. That was in basic algebra again, now you're out of your depths. The series part of calculus I think is fun. The power series I'm not a huge fan of, but like like comparison tests and limit comparison tests and stuff like that for series I think is kind of fun. Power series are they get a little bit annoying though. They can do some fun, or there's some fun things to do with those though too. Okay, so I guess I feel confident enough to answer this person's question. Let me make sure that no one else has gotten back to them first. Okay. Wait, let me just... Common Taylor series. He's down the hall from you? I love this guy's site. Oh, that's awesome. Yeah, I like this is my go-to site for everything calculus. Yeah, I feel a little starstruck now. Okay, I just want to confirm that this series is indeed geometric, and it is. Okay. I was sure it was like cross my wires by thinking that these were related, because they really are the same thing. I think I was taught to these problems just using this like memorization thing. I much prefer this method of just naturally getting to into the geometric like form though. X is greater. Hey, hoo-hoo. How's it going? Lovrink Oman over on YouTube says how to prove sine 10 times sine 30 times sine 50 times sine 70 equals 1/16 with defactorization. What is defactorization? I might be able to work that out, Lovrink. That's a very weird one. I'll probably paste it over to Twitch chat too in case anyone else wants to like be able to read it. I see there's a difference of 20 for a lot of these, and we know what sine 30 is, so that'd be my first instinct with using like addition and difference. It's in trig, some formulas that we had in school. The formulas I'm imagining you need to use for this problem are these ones right here. It's still not exactly easy though. Like I would love to be able to use these identities instead, or Means product to sum? Oh. Interesting. Can we get known? That's equal to one half to the fourth, right? So I assume we're gonna get. We can somehow show these are gonna be a bunch of 1/2s. I don't know how we get all these onto the unit circle though. We can do 70 minus 10. It's gonna be a little weird. We can hope for some cancellations maybe. All right, so I'll try this problem out more and I'll use these formulas down here. Let me just finish typing out this response to this person quickly. For the directions to find just the interval of convergence that you have, or were they to also find the center and radius of convergence, which goes really clear to me in this situation. Okay. I think that's all I want to say to this person for now, and let's see if they get back. Okay, so cosine of 60 is 1/2. Hey, Anders. 5-bot streak, nice. We have this first situation. I guess let's try it. Let's just try it out. Okay, there we go. So we're still going to get some non-unit circle stuff if we just blindly apply the formulas, but I'm going to hope they cancel out. All right, so let me copy down the product to sum formula. If you have sine theta times sine, was it phi? Yeah. Cosine theta minus phi. Minus cosine theta plus phi. Over 2. Okay. Then the actual problem itself is sine 10. We want to prove sine 30, sine 50, sine 70 is 1/16. Okay. So I'm going to notice that 70 minus 10 is 60, which is unit circle, and that we're going to get a 70 minus 10 here. But then we'll get a 70 plus 10 there, which is what's confusing me. And that's what I'm hoping is just going to cancel. I don't have to worry about it too much. I don't really know, though. Sine of 30 we could evaluate directly as 1/2. I don't know if we want to do that yet, though. We might want to keep it there to use with the identity. So let's have the sine 30 and sine 50 just out front and keep them where they are for now. Then with the sine 70 and the sine 10, we'll have cosine 70 minus 10 is 60, minus cosine 70 plus 10 is 80 over 2. Oh yeah, we're trying to prove this. Let's not keep the equal to 1/16 here. So this is 1/2, this is 1/2. Should we actually do this? We might want to do this. So let's say sine 30 is 1/2. And maybe let's see where this simplifies. This might be premature. I'm gonna bring that over 2 out front there. So we're gonna get 1/8 sine 50 minus 1/4 sine 50 cosine 80. Is 50 plus 180 is 130? There's no way that's unit circle, right? Hey, syntax error. Just learned about Dirichlet. I forget. I think it's how you pronounce it. What function? Yeah. I don't blame you there. Is 130 degrees unit circle? Let's find out. It's 90 plus 40? No way. 130 is not a unit circle. It's unlucky. You know, let's just try applying the other sum to product with sine times cosine and just see what happens. Burn it all down, party when? Okay, so if we have sine times cosine, we have sine of the angles added. Which I hate. And then plus sine of the angle subtracted. Does it matter which one goes first? The angle that goes with sine is subtracted from the angle that goes with cosine. So it's sine of negative 30, which we can deal with. I kind of hate everything about this. Because sine of 50 and sine 130 don't really relate to each other in any way, do they? So we get... If we can prove these are 0, we're in business. The thing is, they're not offset by 90 degrees, so we might not be in business at all. Well, ooh. $90 minus 50 is 40. 90 minus 130 is negative 40? Did we do the cosine identity? Which is sine theta equals cosine of pi over 2 minus theta. This might actually work. This is so crazy. So sine of 50 is cosine of 90 minus 50, which is 40. Sine of 130 is equal to cosine of 90 minus 130 is negative 40? Oh my god. Did I do it? Cosine is an even function, so negative 40 turns into positive 40. So these two babies become 0. So we get 1/8 times a half is 1/16. Oh my god. Sine 50 equals sine... It does? Wait, am I stupid? Sine 50 equals sine 130? Wait, what? I got to it in a roundabout way, nothing else, but how do you know that sine 50 equals sine 130? They're offset by 80. Draw it? Like, the actual, like, the wave? Like that? Sine 50 would be around... Oh, they're each 40 away from 90 degrees. I get it. If 90 degrees is right there, you use the symmetry of sine because, like, you know, 50, let's just say it's right there, and then it's 40 before 90. The other one is 40 after 90. Okay, that's fair. I got to it a roundabout way, but I get it. Okay, so Lobrank, if you are still here... Oh, you are, okay. Okay, I explained it terribly because I didn't know where the problem was going, so let me know if you have a question, but if you're good, then... that's even better. Okay, I need to give out saves both for the last problem and for this problem. Okay, so for the last problem, Fenbox helped. Jed helped. Ian Stuckey helped. And Math Professor helped. Also, hi, Thunder. I see you ooh-whopping. And then Stuckey helped with this one. Oh, Milk helped with the last one, too. There we go. I always forget about saves, so... Okay. Nice problem. Yeah, I agree. And Gamer Boy over on YouTube, hey. Hopefully Enigmabot can handle all that. There we go. Enigmabot's a chat. We're good. So yeah, thanks for the problem, Love It's good. I have a test tomorrow at oh, you have a test tomorrow. It is 2300 here, and I have a late night math session. Nice. Well, hopefully you're able to get some sleep before your test as well. Okay. Sorry, I saw there's a new post in my Discord, but it's not anything that I need to read now. Okay, this person didn't get back to me, which is fair. Let's keep looking for questions out in the wild world. Cyclotomic polynomial terms? I don't know what that means. Hey, Cruz. How's it going? Yo, Bob. Nothing much. How about you? I'm doing good, Cruz. Do you have a problem today, or you're just chilling out? Either's fine. Yeah, Fembox. Sounds like there's gonna be a ton out there on Reddit. Function polar coordinates, just chilling? Alright. I appreciate it. Oh. It's an interesting question. I think this person is thinking of something like the vertical line test for rectangular coordinates, and if there's an equivalent thing for polar coordinates, and I don't think there is. I think for polar coordinates, anything kind of goes. Ooh. I don't know, though. Do you know what is lithogram? That sounds like whatever that medical procedure is where, like, you get your lips, like, injected or something. I doubt it's actually that, though, to make them look bigger. What is a lipogram? Oh, yeah, I was very off. Composition from which the writer systematically omits a certain letter or letters of the alphabet? Oh. That's super weird. So you like write a story or something, but you don't use the letter S or whatever. Interesting. Do polar coordinates let you rotate graphs? I guess what like a graph in Cartesian or a graph in polar? If r equals f of theta, then we should have array tests from the origin. Give you 5 sentences about letter E, but it's screwed up a few. It sounds like ChatGPT. Really, you can have array tests? But I feel like I'm thinking of the types of polar curves that they're almost like a heart, but they have a little loop in them. I mean, maybe those aren't functions, but we graph them anyway. It's like r equals 2 minus 3 cosine theta, maybe? Or maybe I need to make it 4 minus 3 cosine theta. Oh yeah, like this. It's like this would fail array test, presumably, if your array goes out along, like, you know, pi. But, I mean, they're different thetas. Like, or actually for... No. For... What would be... I guess the issue would be that you're intersecting itself at 0, right? Because you input... No. For the same theta, you get 2 different r's would be the issue. Which... I've definitely had someone give me like r squared equals 2 minus 3 cosine theta or something like that. Which looks like a butt, yeah. This looks... Is there a butt in here? It's almost like 2 people touching butt to butt, right? But their butts are intersecting, so it's not quite right. If I have a string and I make a lipogram function to remove r, I will get sting? To hug? Oh, okay, that's a much nicer way of thinking about it, but yeah. Double button. Yeah. Butt sucking. That's what it sounds like to me, Cruz. Like, if it's just... it seems like the spirit of lipogram would be to get a completely different word that also means string that doesn't involve r. But yeah, it seems like a lipogram is about, like, removing letters, I guess. Okay, for a given value of theta... It's definitely a but, you know, thank you for your 2 cents there, Bob, and your 2 bits. Oh wait, so Fenbox earlier was put... That was the answer to the question, where if you can solve it for r equals f of theta, you're good. Cool. Wait, r equals e to the theta? How does that look? Well, this person said it's a spiral, but I want to see it. Oh, well, Wolfram Alpha could choose a better plot there, but I guess it's spiral. Draw you, Bob? Oh no, I haven't seen you in a minute. Okay. I'm looking for your Discord. There we go. Okay, that's you. I don't know why your Discord profile picture has your giant nose, but you know. Just send... Okay, that works. What kind of subjects should you expect in Calc 2? It can vary. $25. Thanks for the follow, Kekash. In Calc 2, you should generally expect to do more difficult integrals than you encountered in Calc 1. And you should expect to deal with sequences and series. Well, more like series. So if you're interested in what you'll see, I would go to Paul's online notes, click on Calculus 2, and normal things that you would see are, would you see parametric and polar coordinates? I think you do. I think you would expect to see these first 4 things. The parametric equations part, I think I did that in Calc 2 also. Okay, there we go. That's the Bob that I remember. God, that's the best beard on Twitch, apparently. All right, let's integration techniques for a month, something for 2 weeks, series for a month, something for 2 weeks. All right, we gotta draw Bob. Are you out from your classes now, Bob, or what's the deal with you? Okay. If you draw me, you have the best beard on Twitch on your stream. Doing some stats a bit, so you're here now to sponsor your stream. Okay. That's right, yeah, you did say you're about to take a stats class. Okay. I want to add some color to this drawing, but like I don't know how. Because you used to have like black hair, so. All right, fine. We're just going for it. All right, so you got like actually, I had to bring up that picture again. Integrals are your enemies. They can be pretty tricky. Okay. Draw you like top left, like where the Twitch chat is. Or below it. I need to. Okay, is that where the Twitch chat is? That's just below it. Okay. Oh, good. You don't want to be covered up, Bob. Kowalski analysis. All right. I'll start you from here then. All right. So you got like kind of the double part on your hair, right? And then I remember you having that like, you know, very glorious ponytail. Which I don't know how. Oh God, it's. How do I draw that? So I feel like I'm gonna make you look like a girl. Which I mean, you know, it's my drawing, so maybe I'll just make you look like a girl. But yeah, you got your nose there, a big old smile. You look a little high with your eyes, but you know. You know, I'll make sure this is like a good picture because I'm so known for. I don't even know how to draw long hair apparently. Okay, you got some shoulders there. Here, okay, maybe your long and flowing ponytail will come out the back there. And then we also, you know, we can't forget about your beard. Then what, you have like a little bit of a stash? Yeah, okay. So, you know, you don't quite have those like connectors. So I'll just kind of draw them nearly there, but not quite. I don't, how far up does your beard go? It seems like it goes pretty far up in that picture. I'm sorry about your eyes. The more I look at them, the more ridiculous it looks. All right, you know, I feel like this is coming together though. We can give you like a nice like blue shirt. That'll be some color, right? Oh God. Yeah, this shirt's a little lopsided, isn't it? Okay, and I feel like you would have stripes on your shirt. I don't know why, but I don't know why your head is bigger than your torso. But, you know, this is a perfectly accurate drawing, so it's your fault for, you know, being so disproportionate. It's There we go, some perfect hands there. You get green pants. How about that? Get some pockets in there. There we go. This is shaping up pretty nice. In red shoes, because I just love wearing super random colors. There we go, perfect. One-to-one recreation of Bob right there. Big head equals big brain. Beautiful, thank you, thank you. Oh good, Andrews is getting on the ooh up too. Worth every penny. Yeah. All right, so we're looking at lemniscate. Lemniscate, that's the infinity sign, right? What's the equation of a lemniscate? Oh, that's like r squared equals sine theta. That's what I was looking at before, right? No? New Discord profile picture? Nice, yeah. I won't even charge you money for my hard work there with my art. The lemniscate symbolizes the endless infinite nature of energy. Doesn't energy add to 0? Maybe I'm taking... maybe Charlotte, the people at Charlotte Douglas Yoda... Yoda? That's true. I did get 5,000 coffee beans. That is a lot of coffee beans. Why would no one tell me the equation of a lemon escape equation? Polar. R squared equals a squared sine theta, so maybe this needs to not be 1. 2. Say what? Let's go to Desmos. I don't trust you, Wolfram. Oh, that's right. Desmos doesn't like R squared. Ugh. Oh, that's a balloon. Anyway. Okay, never mind. Desmos is right. What was the... I don't know why I'm obsessing over this when it's really not that important. If I don't find... Okay, I can't find it. You know, it's fine. I'm not going to answer this question. I like the ray test. It makes sense what to do. It feels like there should be things that are functions that would fail the ray test, which I can't quite come to terms with. Okay, so sounds good, Phobos. If it's handy, then I'll take it, but no worries if not. Circulation of something on a path? Oh, this is like advanced calculus stuff, okay. These are things that I want to restudy, like curl. I don't know what circulation is. It might be like divergence or something like that, but... For now, I don't have a very good answer. R squared equals 4 sine 2 theta. Oh, okay. 4 sine 2 theta. There we go. Thank you, Phobos. Yes. I remember Critical Thinking posting a question involving, if not this exact curve, then something like it. And so yeah, I can get how this would... To me, this fails being a function because for one value of theta, we get 2 values of r. So your GRE said it. Oh, that's crazy, Phobos. But there's like less exotic things, if exotic is even the right word. I don't think it is. Like this, it would fail the ray test, but I feel like this is a function. That's why I'm having issues with like this. If I want to say that's not a function, then I guess fair, but I don't really see why. Because you do get multiple values along theta equals, well, not theta equals, along like, you know, this part of the axis. That's because you get negative radii out here. Because if theta equals 0, you get r equals -1. If theta equals pi, you get 5. And then the value of 0 that we get twice, where does that one come from? Wherever cosine is equal to 2/3, I guess. Just a unit circle. So yeah, that's what I don't get about that ray test. Unless you want to say that that isn't a function, but I don't see why it wouldn't be. Hmm. I know that's a save for finding the equation. All right, looks like kind of already out of questions on Reddit, which has been par for the course for a very long time now. I might just go over to abstract algebra. I think we used to have days where like we could just get a bunch of questions off Reddit and be cruising, but this has not been here for a minute. I don't remember what I've been doing with abstract algebra. Oh, it sounds like Minecraft music. I think it's just Minecraft-like, though. To be fair, any relaxing piano song sounds like Minecraft music. All right, so quick refresher on what a group is. A group is closed, a group is associative, a group has an identity. How dare you? You know, there's more to relaxing piano music than Minecraft music. Still in chapter 2, using the old edition with different problems. Oh. I wasn't really paying attention when Penn Center was doing the last algebra stream. I believe he got all the way through chapter 2 problems he wanted to do, and then started reading chapter 3. This is Eric Sadie plus some lo-fi that you don't care about. Eric Sadie. Yeah, the song that says watching old VHS tapes while I wait for you by E66S. I do have a relaxing piano music playlist favorited, or peaceful piano. It's one of the gymno paid. I've seen that word before. In my head I pronounce it gymnopedia, like how Ted Mosby and How I Met Your Mother would say encyclopedia. I don't actually know how it's pronounced, but you know what? I've been kind of bored of the music that I've usually been using. Let's go to this piano playlist. Might be a little too low key, but let's just try it. I'm already bored, I'm gonna be honest. I don't know. I've been worried about music, but I don't want to use stuff with lyrics for the stream. Eric Sadie of Cannibal Corpse? Oh, really? I thought it was just some like piano person who I hadn't heard of. Hey, Shep. I'm good. How about you? It's nice to hear from you. All right, I'm going to lo-fi stuff that Anders doesn't care about. Which I don't care about either, to be honest. I just kind of want something in the background. Do you have a problem like this in your chapter 2? I think that's an example. Let's see. You're okay? That's good to hear. Better than not being okay. That's for addition. I should draw a kitty cat. Let me see if I can find what this is asking, and then we can draw a kitty cat. You know, I can give Bob a kitty cat. Oh yeah, it's this it's the Euler thing person. We talk about. Okay, yeah, so modular arithmetic is a group. Oh wait, no, this is only similar. Oh, actually, no, this it's an example. Problem 37 asks for the proof. Okay. Oh yeah, that's a different problem for me, of course, but I believe it relies on something. They mention it in the example, how you do it. You solve the equation ax mod n equals 1, and you solve it for x. Do they mention it here? Oh yeah, exercise 11 in chapter 0, which isn't the same for you, of course, but you do this, or like this is the multiplicative inverse, like how you find it, I guess. I guess it's not how you find it, it's that it exists. Never mind. I mean, I guess that would be your proof, though. If you can just prove that in general, or for a particular mod. It's different than that, maybe example 19? Problem 50? Okay, let's go back down. The assertion made. Bob writing a giant kitty cat. Okay. We can do. We can do that. Okay, so okay, well, let's go to the whiteboard, and I'll try to address Phobos's question as best I can. I don't know if I'm. Okay, so I'll try to give my understanding of it, and then we'll draw the kitty cat. I think if 0, 1, 2, dot dot dot, n minus 1. I think we would say if we want to prove that there exists an X for all n in, I guess, that group. I don't know what we call it. S? Probably a bad name. Such that ax mod n equals 1. And if you know that n is prime, actually, oh no, a and s. If you know that n is prime, you could say, this is my idea for how you do it. I don't know if this is right. You can use the linear combination. A times some number we can conveniently call x, I guess. We should know, we probably shouldn't. AT plus NU equals 1. The GCD is 1 because N is prime. And then I think you can rearrange this, I guess, for N? How does this work? You basically use this one to be a remainder. I'm forgetting exactly how you do it. But you show this is like division. This isn't quite right, though. I'm forgetting now how you actually do that. Maybe the same method is needed as you point out for the other side of U of N group. Yeah, I mean, it is the same thing. It's just that when you have a prime, you don't have... Oh, you can't have 0 in the set? Oh. My bad. I think you improve... So, I guess in some reason, I think you improve the inverse exists without actually finding it. I can't remember how this proof works, though. I think the reverse direction was easier, where if you know AX mod N equals 1, at least I remember thinking it was easier. And then you can reverse the steps. AX mod N equals 1 implies... how does this work again? If you have 5 mod 4, that means, okay, so that means AX is equal to some number T times N plus 1. Oh, duh. Okay. And because you're just looking for AX, not A individually, or X individually. And so, yeah, in this situation, you prove the GCD is 1 because you can find a linear combination of them that adds to 1. So you can do this in reverse. I'm doing a terrible job of explaining this. Yeah, referring back to chapter 0. No. For prime N. What? Oh, God. My Dark Prince. What the fuck is it? Okay. Why do they think that doing 4 messages from different accounts is going to make it less suspicious? Like, I don't get the play there. Yeah, so I feel like you can use that previous example, or the AX mod N equals 1 as like that's what it means to have a multiplicative inverse if X exists. And you can build your way to that from the fact that N is prime. So the GCD of N in any element of the set should be 1 because the elements of the set do not include N. Yeah, and I think Fermat's little theorem would be the shortcut. That hasn't been presented in the book, I don't think. But I think that would make it shorter, Bob? Let me draw this cat because it's like on my mind, and then we'll look into this more. I feel like blue is a good color for a giant cat. That... That's a weird neck. It looks a little more like a dinosaur right now. But trust me, this will come out to be a perfect cat. Got a bit of a pooch. It's also it's a wiener cat. Has a very long body, just like a wiener dog. Well, I guess the tail should be connected, right? There we go. This really screams math stream, doesn't it? Oh, that's a terrible nose. Ta-da! A little, like, cat toes. We can draw some, like, I don't know, should we draw spots? No, I feel like I'm gonna make it look weird. How's that? Well, he's surfing on the cat. Love it. Glad that you like it, Shep. I guess it was Anders who redeemed it as well. You two, dude, I can't even be rusty at number 3. I never learned it in the first place. You go back to bed? Oh, you don't have to apologize for that, Shep. Thanks so much for saying hi. I hope you get some sleep. So yeah, I want to give a good answer to this problem here, because I'm pretty sure I can do it. If Anders is saying if n is not prime, then n equals ab, with 1 is less than a is less than n, 1 is less than b is less than n, right? A and b belong to the set 1 to n, but 0 equals ab mod n does not. Oh, okay, so you're showing that you would not be closed if n is not prime. There's a little text that if a and b are relatively prime, there exist integers. Yeah, Fenbox, we were trying to do something. I was trying to do something like that. I was just getting tripped up on the actual mechanics of it. Just got home from work. Ah, no worries, Fenbox. I want to write it a bit better just for my own benefit. Oh, the problem is covering up Bob and the cat a bit, but so I mean I think what I had here is nearly good. I just need to bring the NU to the other side, not the AT. You want to prove maybe because x is the multiplicative inverse of A. So since n is prime, we know there's a linear combination of A times something plus n times something is equal to 1. And then we want to bring our n times something to the other side. And this looks just like the division algorithm, which would imply that AT mod n equals 1. And for fun, you know, I didn't want to use x for some reason, but we can take t equals x, say ax mod n equals 1. I don't know if that's like the right way to avoid using x until the end, or if you just use it off the bat. But I guess that's how I would do it, which doesn't say much. It's hard to prove on screen, yeah. I mean, we may as well look at the rest of what it would take to prove that this thing will be a group, right? How would we prove closure? I probably should give out some QEDs. Bob, Anders, and Phobos, I think. For any k in 1, 2, 3, n minus 1, the missing exists integers a, b such that ak plus bn equals 1. Right. Now read mod n to show that ak equals 1 mod n, and mod n is the, and a mod n is the inverse of k? Oh. So you can just take mod n of that linear combination, and you know that n, you know, bn mod n is 0. And if ak mod n is equal to 1 mod n, wouldn't that mean ak mod n equals 1? Because you know 1 mod n directly, but you don't know ak mod n. I think that's maybe a cleaner way to do it than what I said. So you have ak plus bn equals 1. Take mod n. We would have ak mod n plus bn mod n equals 1 mod n. ak mod n we don't know, I think. bn mod n is 0. 1 mod n is just 1. So I think this is probably a better way to do it than this weird... I'm not a huge fan of like this step to this step. It just feels weird to me for some reason. So I do like this version of things. I hope I'm interpreting you right though, Femvox. So you're thinking, okay. Do you need to prove A is not 0 mod n? Does this not take care of it? So I think that being able to write them as a linear combination equaling 1 is going to remove that possibility. Or just like n being prime already. Yeah. Unless I'm misunderstanding. Um... We leave it to the reader to check the set as closed under this operation? That's what I wanted help on. Like, I know how to manually check that this is closed. How can we generally prove that this is closed? Um... That's fair, Andrews. I feel like that should maybe, before we even get to this point, we should maybe mention that if we're trying to prove that this is closed. Because that's what I'm trying to do in my head right now, and not being able to get to 0 is important there. So think if I was doing this question from the beginning. Bob, it's still a problem above. I think we've addressed Phobos's question, but since we're already on it, I kind of want to do the entire problem, which is proving that it's a group. So yeah, I was starting with the closed part, proving that this is a group. And so we have to eliminate 0, and then the rest kind of naturally follows, I think, from the remainder being less than n. Let's try to maybe like write this entire thing out. So let's call this group A. Actually, they were saying U, I guess. Say U of N. Wait, multiplication? Multiplication mod n if n is prime. Right? Oh, if and only if. Oh, so actually we have two directions to prove here. That number A that's guaranteed to exist by Bezout's lemma might not even be in 1, 2, and minus 1. We read mod n, we can make sure that... Okay. Then as prime, the only factors are n and 1, so the problem will be... Um... I think it'll be... I want to... I didn't realize this was an if and only if. I want to start doing the direction that n is prime implies u of n is a group. So if we want to worry about closure first, this is not the group u of n? I thought it was. It's I can change my naming scheme. Let me show why I was thinking that though. In the case that n is prime, u of n equals that. That's why I was saying that. Yeah, yeah. Okay, so if you want to show those things close, we have to worry about 0. And then I feel like the rest should be clear because we're either assuming or we've proven that the remainder is unique and it's less than, and it's between 1 and n, not inclusive to n. It's not equal to 0 because n is prime. I feel like that's all justification that we need for that one. Unless we want to go further like Bob did. I don't know. I don't know where to stop, I guess. You'll call it UP if we're proving the if part. Oh, yeah, if you wanted to do like the reverse direction. I'm starting with n being prime, implying that U of n is a group. The reverse direction, I'm not sure how it's going to work yet, but... What is, it was in chapter 0, the division algorithm, or how, what defines the constraints on the remainder? I want to use this thing right here, so I guess we're calling it the division algorithm. It's kind of a lame name, but okay. Is less than or equal to AB. N is less than N. But, or I guess we'd say and. All right, but by the above, 0 is not equal to AB mod N. So 1 is less than or equal to AB mod N is less than N. That's my idea for proving the closure of this. I don't know if this is right, but it feels right. Associate, how do you spell associate? Associa. I think it's how you spell associative. How do I not know this? Okay, I got it right. I agree with what No Pro Bob said about just making sure that if A and B are in U of P, then AB can't be 0 mod P, so we have to have closure. So do you agree with going to the extent that Bob did? Because I thought just N being a prime is enough. And you know that AB can't be more than N by the same division algorithm thing, so maybe I could rephrase what I'm doing. I guess for associativity, we're going to need 3 elements. How deep do I have to go to prove associativity? Oh, wait. Oh, this is maybe going to be harder to prove than I thought, because we get a second mod n out here, which I didn't think we'd get. Ooh, can I do it this way? I just want to say multiplication is associative and leave it at that, but it feels like cheating, right? Associativity is inherited. That'd be a lot easier, Fembox. So yeah, I thought this was the. I didn't realize we would get that mod n that's right there. I thought I'd just be able to like break it down to 3 mods like that, and then associate B with C, and then have it, and then bring in A. I much prefer your idea though, because this I don't know what to do with now. Sure, that's my proof. Obvious, trivial, clearly. Identity. Our identity is 1, right? A times 1 mod n equals A mod n, where all A belongs to U of n. And I guess we already went over inverses. For some, oops. For some integers s and t. This exercise is left as an exercise to the grader. I love that, Phobos. It's the Uno reverse card. Now we take the mod n of everything. I think I like Fembox's approach here the most. Actually, I did forget the mod n, or I didn't exactly do the mod n quite right the first time, right? Because you have as plus nt mod n. You're gonna, I forget what extra mod n you get when you split up mods. This implies as mod n plus nt mod n, and then this mod n on the outside I completely forgot about. One mod n evaluates to 1, since n is greater than 1. As mod n is what we want to solve for. Nt mod n is 0. How do we deal with this double mod n situation, actually? I didn't realize that we would have this when I did it earlier. If you mod n twice, is that like modding n once? Does that not accomplish anything? Right. Yeah, this extra mod n doesn't actually do anything. Because when you do as mod n, you get something that's less than n. And if you do something that's less than n mod n, you get that same thing back. Okay. So S is the inverse of A. Oh, that's for right multiplication. Do we need to show technically that SA, that like this S is also the left multiplication inverse? Can we just say that multiplication is commutative and leave it at that? Okay. There. That's enough? Okay, thank you, Bob. If anyone at all said yes to that question, I would just believe them because I don't want to do anything else. Okay, so I think I'm happy with this for that direction. I think the reverse direction might not be that bad. I think I had an idea when I first started writing out the closure part for part 1. I don't really remember now though. So if we're given that U of n is a group now, then we have to know that n is prime. Hey, warm-hearted American girl. How's it going? How many coffee beans for the left inverse? I mean, if you really wanted to be, I feel like this is just the left inverse. So it'd be like 1 coffee bean because like that's just a bit of extra writing. You could technically repeat that entire argument and just switch S and A, I guess. But if we're already doing this like exercise left for the greater, I feel like we can do that exercise left for the greater. I like your beard. That is like, thank you. That's probably like the best compliment that you can give me. I do pride myself on my beard. Even if technically No Poor Bob has a better beard, but you know, we don't have to talk about that. So I assume if we want to do this part, we would have to shows a problem with U of n being a group if n is not prime. Let's see if we talk about that. Yeah, Bob. So I have there's something called Drawback Chess. It's a website that could be fun. I played it with Anders before. It's like chess, but you have some kind of drawback, like if your opponent captures a piece with their same type of piece, you instantly lose. Like if they capture your bishop with their bishop, you just lose. Or like I think there's one like if a piece is behind a pawn, that piece can't move until a pawn moves. It's like a whole bunch of like crazy like rules, and you each get your own drawback. Oh, you played it? Okay. You can do that for the crown of the best beard. You have harder drawbacks? Yeah, if we can control that, that would be cool. Because you are like way higher rated than me. Because I do have some stuff on board game or on tabletop simulator too, but I feel like drawback chess might just be better. Even though you have an advantage with like chess stuff. At least like a variant. Code names when? I mean, do you mean code names when in general or code names for the best beard? I don't know if code names will really work for the best beard. Actually, there is like a 1 versus 1 version of code names, isn't there? I don't remember how it works. I think it's more co-op though. If you're asking about code names in general, I don't know. last time I tried to organize it, it just fell through, so I'm not really that keen on trying to organize a big group thing again. If you don't stream for a certain amount of time, best beard title has to be forfeited, you know? That's true, Bob. You haven't streamed in like 2 months or something. I'm a fan of that rule. I guess we didn't. The rules of the beard are very clear, and we haven't written that rule yet. Oh, you know, we can use this closure issue if n is not prime. Speak this exact thing with being 0 mod n. I guess this might be what Bob was doing before, to be honest. I feel like I'm using that argument. If it fell through, you need a better sieve. That's true. You like Donda doesn't even want to claim the title that way? Yeah. That'd be lame. Best beard currently streaming? Yeah. Best beard currently streaming on a Tuesday in the math category. No. Yeah, I want to like beat the champ here. Not mess with the rules. Use all my proof words. However, a b mod n equals 0. Oh wait, no. I could say so a and b belong to u of n, but a b mod n equals 0. And 0, that's theta. What is theta if not 0 with little slash? How do we phrase this? So the binary operation is not closed. So this multiplication is not closed. I guess U of N is not closed. I'd hope that's enough for the reverse direction. Oh no, Fembox, you're good. Yeah, so basically the lore is me and Bob are like, you know, jokingly going back and forth about who has the better beard. And of course, then Bob was streaming more frequently. So you could actually admire his beard. And so we finally have a beard off, which was in the game Infinite Craft, if you've seen that. It's like a game where you just can combine words to make other words. And so in theory, can craft any word ever. So we randomly generated 9 words. Well, we made one of the words beard. You're like, okay, first person to get 5 out of 9 of these words wins. It was terrible. We could not make some of those words. It was like abstract words like perseverance or some like stupid stuff. So after like 4 hours or something, we just started adding on extra words that we could then craft, and then Bob beat me to one of the ones that we added. So I was like, oh, okay. It's an Australian band called The Beards, really? That's true, yeah. Bob to get the actual word beard first. It's gonna be a super long time to actually get beard. All right, are we saying that's good enough for 50? I think I'm saying that's good enough. Problem. Your dad hasn't got a beard. You've got two mums. I love that. Except Frank, really? One second. I'm getting a phone call and I need to take it. I'm gonna put it on my BRB screen. Okay. I'm super sorry, but I need to cut the stream. My car's been in the shop for over a week, and I just got the call that it's done, and I'm really sick of not having a car, and I want to go and get it now. And I need to like rush over there before they close. Is there anyone who's streaming now that I can raid? If not, I'm just gonna have to end stream here. I don't have anyone on who I'm following. Man, I would have loved to do some more algebra, but it's been over a week since I've grocery shopped, and I want food. Okay, I don't have anyone who's on right now.